Okay, you guys, we're gonna have a paper cup over a candle. We want to see if the water in the cup today will come to a boil, or if the candle underneath the cup will cause the paper cup to catch on fire. So one of the conditions for this lab, we said, is that the flame actually has to touch the paper cup. So I want to do that for each of these tests just to make sure that it's a fair test. Okay, so I can see our flame here, and we are going to put it directly under the cup. And we want to see if it catches on fire or not. And typically, if you've got paper that's touching a flame, it burns. So if it doesn't burn, could you tell me what kind of heat transfer would prevent the paper cup from burning right
Conduction.
now? Chase says conduction, okay. So I know that the cup is solid, and I know there's liquid in it, there's water, so it's likely that the heat from the candle is moving from the cup to the water. Now, what kind of heat transfer, Erica, is just coming off the flame? A candle.
Radiation.
Yeah, that's radiant heat. Now, I kind of want to see if we can get the water in that little cup to come to a boil. So we're just going to let that sit over that candle for a while, and we're going to see if you can actually get bubbles in a paper cup over an open flame. That'd be kind of an interesting phenomenon. So I'm over here with Caden Boulder. Caden, we want the very same conditions, okay? So we're using the same candle, same cup, same amount of water. And again, the question is, why doesn't the paper cup burn? Why doesn't the cup catch on fire if it's touching a flame, all right? So Caden, you ready? Here we go, we're gonna put it right underneath it there. Okay, I can see the flame. Now Caden, if the cup doesn't catch on fire, why not?
Because of the water.
Because of the water. Okay, what kind of heat transfer would prevent the cup from burning?
Conduction.
Conduction, okay. What kind of heat transfer is the candle itself? The flame.
The flame.
Is that convection? Is that conduction? Yeah, that's radiant heat, okay? So you keep an eye on that water, Caden, and you see if some bubbles start rising up. I can actually see the flame in the bottom of the cup. I'm gonna come back over here and just get an aerial view. I can actually see the flame in there. Yeah, I see a black spot, but I can actually see the flame in the bottom of the cup. Okay, so let's come to table 3 over here. Table 3, same conditions. I'm over here with Logan, Caden Franklin, okay? We got the same kind of cup, same candle, same amount of water, all right. And the question is, why doesn't the cup catch on fire? So here we go. All right. We got our candle burning here. Let's get it right underneath there. This one might be so close that it actually snuffs the candle. So I'm gonna try it again. And Logan, would you unscrew the corner there and just lift the cup about 1 centimeter? Just a tiny bit. Yeah, that's good, that's good. Okay, now see if you can lower it. Because we really want the flame to actually touch the paper. That's good, well, yeah, that's good. Just as long as it doesn't go out. But we want the flame to touch the paper. Now Logan, if the paper doesn't burn, the question is, why doesn't it burn?
Because of the water.
Okay, there's water in the cup. So what kind of heat transfer is that? From paper to water is conduction, right? The paper is solid and it's going straight to a liquid. I want to see if you can see the flame in there. I can see it. So Caden Franklin, do you think the water could boil in a paper cup like that if we wait long enough?
Yeah.
Maybe? Okay, we're gonna find out. So I'm over here with Alicia and Diego, and we've got our cup, got a little bit of water in there. And Alicia, we wanna see if that paper cup will burn. I'm testing heat transfer here today. So this is radiant heat, it's a flame, right? And the cup is solid and it's going to a liquid. So we're gonna put it right underneath there. We want to see if the paper burns. Now if the paper is burning, should you smell it? You should smell some smoke coming off the paper, right? I don't smell anything.
I do.
I don't see anything burning there.
I do.
Do you? Let's look down in here. Let's look inside. I see a little dot where the flame is, but I don't see any evidence that the paper cup is burning. So, question to you, Diego, why isn't it burning?
There's a water.
Okay, there's water in it. Is the heat transferring from the flame to the cup to the water?
Yes.
Okay, what kind of heat transfer is from the cup to the water? What kind is that?
Conduction.
That's conduction. What kind of transfer is from the flame?
Radiation.
That's right, Alicia. That's radiation. Keep an eye on that. See if it boils after a few minutes. And I'm over here with table 5. In table 5, we've got the same cup, same candle. Let's see if the cup burns. Let's investigate heat transfer today. We're looking at radiation and conduction. We're going to put that right underneath your cup. We want to see if the paper burns, and if it doesn't burn, we want to think about why. So what do you think? If it's not burning, why isn't it burning?
Because of water.
There's water, okay. Ava, what kind of transfer happens between a solid and a liquid?
Conduction.
It's conduction, good. And I'm over here. I see you got Bickles with you there. So, Alex, what kind of heat transfer is the candle? Just the candle
Radiation.
flame. That's radiant heat, good. And if we look through the top, you can see a little flame through the top of the cup. And we want to see if this water can actually come to a boil. So I'm going to come over here. You guys keep an eye on that. And I'm over here with table 6, and we've got the same test that's set up. And let's light our candle and put it right underneath our cup. And we want to see if we can burn the cup or if heat will transfer from the cup to the water. Now, if the cup doesn't catch on fire, Cristiano, what kind of heat transfer is that?
Conduction.
Yeah, because it's going from the cup to the water, and I can see the flame underneath the water there. It does not appear to be burning. So let that stay underneath your water for a while. Let's see if it boils. Okay, to my last table here, table 7, with Greg and Danon and Alden. We've got kind of the same setup here. We've got a ring clamp, stand candle, and a paper cup filled with water. So we want the flame to touch the paper, giving it the best opportunity to burn, okay? So I'm gonna move this so it's actually touching the paper. We wanna see if the cup catches on fire. And if it doesn't catch on fire, we wanna think about why. So let's look through the top of it. You can definitely see the fire through the top of the cup. Doesn't appear to be burning. So, guys, why isn't the cup burning?
Because the heat transfers into the water.
The heat moves to the water. So, if it moves from the cup to the water, what kind of heat transfer is that?
Conduction.
That's conduction. And then the candle, the flame itself, what kind of heat transfer is that?
Radiation.
That's radiant heat. Now I want to keep that burning and see if you, after about 5 to 6 minutes, if you see bubbles in the water, if you can actually boil water in a paper cup over an open flame. And we'll check back with you guys in a few minutes. And we're modifying the design just a little bit. We still have candles that are heating up water in our back teams, but this cup here, we've added a little bit of water so that the rim of the cup doesn't catch on fire, but we're going to increase the temperature with an actual blowtorch to see if we can boil water in a paper cup without the cup burning. So again, the conditions are it's paper, it's just water, and I'm using a blowtorch to see if we can get some bubbles really quick. So here we go. Okay, do you see bubbles? Look over the top, guys.
Yep.
I can see bubbles, and it doesn't appear that the paper is burning. And that's definitely a paper cup, isn't it? Okay, let's look at the water. Is the water boiling?
Yep.
I'm going to turn it off, and let's look at it. Let's look at it. Okay, look at your water.
Can't touch it.
Yeah, I can see some convection currents and the water is swirling.
I can see
And we saw some bubbles climbing outside, but again, if we inspect the cup, look at the cup. There's char marks on the side, but it's not really burned. So this is extreme heat transfer
on the bottom.
from the cup to the liquid, even using a blowtorch. Pretty cool.